morning, dear students. So far we have discussed with the term moment of force, effect of force and the pressure. So the pressure, now this relation, that is the term pressure, has come from the effect of force. Now effect of force depends upon the surface area in which a body comes in contact, as well as the amount of force which is applied on that body or an object. So related with this effect of force, I will explain you about the two examples. One is a pencil holding between the two index finger, and one end of the pencil is blunt and other end is pointed. So when you press the pencil which has been kept between the index finger, you will have a deep impression, or you will get hurt on the region where there is a pointed end. So the pointed end has got a smaller surface area. So some smaller surface area makes greater pressure. And also I have explained you about the bricks, the 3 bricks we have taken. First you take one brick and you keep it on a mud or a sand. The brick will not sink. And in the second condition, in the second case, on the top of that first brick, you keep another brick, or you go on increasing the number of bricks there. What will happen? The brick will sink. So that means as you go on increasing the number of bricks, the magnitude or the amount of force increase. So more the magnitude of the force, more will be the pressure. So due to that pressure, the brick will sink in a mud or in a sand. So this example I have given you related with the effect of force. And this effect of force gives the relation between the force as well as the area. And that relation between the force and the area measures the physical quantity known as the pressure. So pressure is defined as the force acting on an object per unit area. So in an object, when the force acts on it in a unit area, then we call it as a pressure. So pressure is defined as the force acting per unit area. And the 2 units of pressure are there. One is the CGS unit, other one is the SI unit. The CGS unit of pressure is dyne per centimeter square. CGS unit of pressure is dyne per centimeter square. So how it comes is that the CGS unit of force is dyne and the CGS unit of area is centimeter square. So therefore the CGS unit of pressure is dyne per centimeter square. Likewise, the SI unit of pressure is Newton per meter square. The SI unit of pressure is Newton per meter square. The SI unit of force is Newton, SI unit of area is meter square, so therefore SI unit of pressure is Newton per meter square. And this SI unit of pressure is also known as Pascal. P-A-S-C-A-L, Pascal, which is written as P-A. And this Pascal, actually it is the name of a French scientist. Okay, he was a French scientist named as Blaise Pascal. So in the name of the scientist, the SI unit or physicist, the SI unit of pressure is also known as Pascal. So this is the CGS and SI unit of pressure. Now from the definition of the pressure is directly proportional to the force. So pressure is directly proportional to the force, or pressure is inversely proportional to the area. So pressure is directly proportional to the force means if the greater the magnitude of the force, greater will be the pressure. More the amount of force applied on an object, more will be the pressure. Lesser the force applied on an object, lesser will be the pressure. Likewise, pressure is inversely proportional to the area. Inversely proportional means if the area, if the surface area in which the body comes in contact is more, if the area is more, pressure will be less. If the area is less, pressure will be more. So that means they are inversely proportional. Inversely proportional means if one will be more, the other term will be less. Okay, but indirectly proportional, if one will be more, the other portion will also be more. So that means if the force is greater, pressure will also be greater. If the force is less, pressure will also be less. But here, if the area is less, pressure will be more. If the area is more, pressure will be less. Okay, so therefore, this gives the relation of pressure. So therefore, when we discuss pressure, pressure equals to force divided by area, or also known as thrust, T-H-R-U-S-T, thrust divided by area. So you can write here either the force divided by area or thrust divided by area. So thrust is also the force, but this is the force which acts on an object perpendicularly. So when a force acts on an object perpendicularly or normal to the surface, then we call it as a thrust. So pressure equals to force divided by area or thrust divided by area. So now the next point is application of pressure. So the application pressure uses, the pressure can be, you can increase the pressure or decrease pressure. Okay, so pressure can increase or decrease depending upon the magnitude of the force and the surface area. So the first one, let us discuss about the application of pressure. That means the pressure can be increased. So how you can increase the pressure? Like when you take the objects like the scissor, axe, knife, okay, all these sharp objects which are used for cutting things. Okay, your axe are used to cut wood, knife are used to cut vegetables. Okay, scissors are used to cut clothes or paper. So these are the cutting material. Now this object have sharp edge. The edge is very sharp, and the surface area of that edge is smaller. So the surface area, being a smaller surface area, by applying a small force, this object can able to cut things, okay, by creating greater pressure. That means the sharp object, all the sharp object has got a smaller surface area. So the smaller surface area produces greater pressure. So by applying a less force, you can cut the vegetables, you can cut food, okay, cloths, all these things you can do it. Okay, so the surface area is small. And the next one is there, like the all pins are there, nails are there, screws are there. Okay, they have got a broad top. Okay, the top region is broad, whereas the other region is pointed. One end is pointed region, other one is the blunt or the broad end. Now this pointed end has got a lesser surface area, and lesser surface area will create a greater pressure, and due to the greater pressure, by applying a small force, these nails, okay, or all pins, okay, this can pierce it into the object by applying the less force, because the pressure will become more. So this way the pressure can be increased. Next one is pressure to decrease the pressure. How you can decrease the pressure? Like the first example, when the buildings are constructed, okay, the buildings are constructed, the base of the buildings, okay, the base of the building are made broad. Now why they are made broad is that in order to increase the surface area, because when you go on constructing the building, okay, the weight of the building becomes more, and when the weight of the building will become more pressure will be exerted by the building. So the foundation of the building should be strong. So in order to make the foundation of that building, the base of the building should be broad. It should be made broad. That means the surface area should be larger. So in order to, when the surface area will become larger, okay, the pressure will become less, and therefore the building will not get collapse. So this is one of the way in which the pressure can be decreased. The other one is there, that is in a railway track. In a railway track, okay, these are the track, the railway track. Okay, and just below the railway track there is wooden sleepers. You can see in the railway track, just below there will be wooden sleepers. Okay, we call it as sleepers here. Okay, just below the railway track, and the railway track are made up of metal. These are made up of iron, and just below the railway track, some wooden sleepers are placed there. Now, why they are placed is that in order to increase the surface area. Okay, the surface area get increased. The surface area between the railway track and the wooden sleepers will increase the surface area. So therefore, the pressure can be reduced. So in order to reduce the pressure, the sleepers, the wooden sleepers are placed just below the railway track. The next one is there, when you carry a bag, okay, you have a school bag when you carry, they have got a broader straps. The stripes are broader. Okay, that means the belt are broader in order to carry. So why it happens is that in order to reduce the pressure. So when the broader part of your bag will reduce the pressure, and therefore you can easily carry it on your shoulder. So there are various ways in which the pressure can be decreased. Now the next one is the pressure exerted by liquids. Now the pressure, like solid, liquid also exerts pressure. And the liquid as well as gases, they are known as fluids. Now fluids are the substances which can flow. So any substances which can flow, they are known as the fluids. So therefore liquid and gases, they are known as the fluids. So the liquid also exerts pressure. They exert pressure in all the direction. But the solid will exert pressure. When we come to the difference between the pressure exerted by the solid and the liquid, solid will exert pressure only on the place or on the portion in which the body comes in contact with the surface. So when you take a stone when you keep it on the table, the stone comes in contact with the table, and the portion of the stone which comes in contact with the table, only in that portion the pressure will be exerted. That means the pressure will exert downward direction. Okay, in a solid. But whereas in a liquid, the pressure is exerted downward direction also, as well as at the side of the vessel. That means when you put water in a container, in a vessel, the water will exert a pressure downwards at the base, towards the base of the vessel, as well as towards the side of the vessel or side of the container. So that means they will exert pressure in all the directions, especially these liquid and gases. So now this liquid will exert pressure depending upon the height. Greater the height of the liquid, greater will be the pressure. So that means more the height of the liquid, more will be the pressure. Lesser the height of the liquid, lesser will be the pressure. And the pressure in a liquid, they exert at the side of the vessel. Okay, towards the vessel also. That means this pressure will exert downwards also, as well as towards the side of the vessel. And the pressure which are exerted at the side of the vessel, we call it as a lateral pressure. They are known as the lateral pressure. The pressure exerted by the liquid at the side of the vessel or container, they are known as the lateral pressure. And this lateral pressure increases. This lateral pressure increases with the increase in the height. So more the height of the liquid, or more the level of the liquid, greater will be the pressure. So for that, the pressure exerted by the liquid, will come to the one demonstration, one experiment based on it. So for that, you will take a glass tube. You take a glass tube which is open on both the end. Okay, a cylindrical glass tube which is open on both the end. So you take a cylindrical glass tube which is open on both the end. So on one end, towards the one open end, you will fix a balloon. Okay, you tie a balloon on one open end of a glass tube, and the balloon is fixed there with the help of a string. Okay, with the help of the string, you just fix a balloon at the one end of the one open end of the glass tube. Then what you do is that now you start filling the water there. You fill the water from the other open end. You fill the water. Okay, and when you fill the water, the balloon will start inflating. That means they pulses out. Okay, that means they increase in size. As soon as you start pouring the water from the open end, the balloon, they start inflating, which means the pressure is exerted on the balloon by the water. by the liquid. Water is the liquid. So this liquid will exert a pressure on the balloon, and due to that pressure, the balloon gets inflated. Now, in the second case, what you do? You go on pouring the water. You go on pouring the water so that the level of the water or the height of the liquid column, it increases. So as long as or as more and more water you pour it into this glass tube, more the balloon gets inflated. That means more the balloon, they increase in size. So that means more the water you keep on pouring into this glass tube, more the pressure will be increased, because as long as you keep on pouring the water there, the height of the water level it increases. So as the height of the water level increases, the pressure will also increase. So as the pressure goes on increasing, this balloon goes on inflating. So which means that the pressure is exerted by the liquid depending upon the height. So more the height of the liquid, more will be the pressure. So this is the experiment in which the pressure is exerted by the liquid. The next one is the manometer. Now manometer is a device, it is an instrument to measure the pressure in a liquid. To measure the pressure exerted by the liquid, we use a device known as manometer. Other one is the barometer. Barometer is an instrument to measure the atmospheric pressure, but here manometer is an instrument to measure the pressure exerted by the liquid. So for that, you take a wooden board. On the wooden board, a U-shaped glass tube is fixed on it. A U-shaped glass tube is fixed on the wooden board, and it consists of a scale in which the scale is also fixed on the wooden board, and this scale will give the reading. In the level of the water in this U-tube. Okay, so there is a U-shaped tube which are here, and both this U-tube as well as the wooden scale is fixed on a wooden board. It is fixed on the wooden board. So it consists of two arms here. One arm is arm A and other side is arm B. Okay, and arm B, that is the other side, is left open, and here on the arm A, this arm A, the tube of this arm A is connected with a container containing liquid. It contains liquid. It is one side of the U-tube is connected with a container containing liquid. So what happens is that now the level of the water which rises on both the sides of this arm in the tube will give the reading on this scale. The scale will give the reading on the level of the water column or the liquid on both the arm of the tube. And that difference between the level of liquid column in the arm A and B will give the pressure exerted by the liquid. So this way the manometer it works. So in the next class we will come to the next point, that is about the Pascal's law and the characteristics of the liquid pressure. Thank you.